For those of you tracking the cutting edge, the phrase quantum leap, it's not just a metaphor anymore, is it? It's actually becoming a very real geopolitical thing. We're talking about a massive shift, really, rooted in fundamental physics. And it looks poised to tackle some huge global challenges. Everything from securing our data to finding new medicines, maybe even forecasting climate change better. Today, we're digging into Europe's pretty audacious strategy to try and lead this quantum revolution. We'll be using official EU sources directly, giving you a shortcut to understanding what's really a critical tech race happening right now. So our mission today, unpack what these quantum technologies actually are, why Europe is putting so much behind this, and, well, what it all means for you.
It's an incredibly exciting field, absolutely. And what's really striking is this isn't just theory stuck in a lab anymore. This is a practical revolution. It's attracting huge global investment, intense competition. So the EU strategy here, it's more than just strategic. It feels foundational for their future. Competitiveness, autonomy, all of that.
Okay, so let's unpack that a bit. We hear quantum technology, and honestly, it can sound incredibly complex, almost sci-fi. For someone already following tech, how would you define it simply? What's the key difference from, say, the classical tech we use every day?
Well, at its core, quantum tech basically harnesses the really strange counterintuitive rules of quantum mechanics. That's the physics governing matter and energy right down at the atomic and subatomic level. So unlike classical bits, 0 or 1, quantum systems, they can be in multiple states at once, the superposition, or they can get entangled, linked together instantly, even far apart. And this just opens up completely new ways to process information. We generally talk about three main areas: quantum computing and simulation, quantum sensing, and quantum communication. Each one uses these unique quantum properties to do things that are, frankly, impossible or just way too slow for traditional tech.
Wow, okay. The scope there, climate forecasting, unhackable communications, it's pretty staggering. I mean, you can almost picture entirely new industries just popping up from this. So beyond just more powerful computers, what are some really practical ways quantum tech might impact our daily lives, say, in the next few years?
Right. It's not just about speed. It's a potential game changer across the board. So computing, yeah, quantum machines could solve problems that would take current supercomputers, well, ages, millennia maybe. Things like designing totally new materials or figuring out complex drug molecules. Then healthcare. Imagine imaging sensors so precise they detect disease super early, or cutting down drug development time from years to maybe months. Cybersecurity is a big one. Quantum cryptography could offer truly unbreakable codes, essential for digital trust, right? Also think about optimizing logistics and transport, global supply chains, super precise navigation systems, and for the environment, maybe more accurate climate models or even earlier warnings for things like earthquakes using detailed subsurface mapping. Oh, and it's really important to mention the strong dual-use potential. That makes it vital for defense and national security too, which just adds another strategic layer.
That dual use point, that's definitely key. And it hints at the fierce global race to get there first. So considering all that potential, where does Europe actually stand right now? Are we talking a leader, or is Europe sort of playing catch-up in this quantum game?
It's a bit of a mixed picture, actually, but definitely promising. Europe has undeniable strengths. We're a global leader in quantum research, #1 worldwide in scientific papers published. We've got a real concentration of top quantum talent, and a good chunk of the world's quantum startups are based here. But the weakness, historically, it's been getting that research commercialized, turning the science into market-leading products at scale. It's that classic challenge, sometimes called the Valley of Death, getting brilliant lab ideas into actual industrial use.
Right, the Valley of Death, a familiar story in deep tech. So that brings us to the why now. Why is the EU putting so much capital, so much effort into quantum right at this moment? What's the driving force?
The why is pretty clear. It's seen as a necessity, not a luxury. It's about future competitiveness, strategic autonomy, because the potential is so transformative. Every major region, all the big tech players, they're investing heavily. They're all looking for those breakthroughs, that competitive edge, better security. And Europe recognizes it's actually really well positioned to lead this next wave if it acts decisively now. So the investment is about capitalizing on that strong research base, nurturing the startup scene, building the needed infrastructure. It's fundamentally about ensuring Europe isn't left behind, and crucially translating that scientific excellence into market leadership, like now.
Okay, so that's the rationale. What about the plan itself? In a nutshell, what's the EU's vision for quantum? And how are they planning to bridge that valley of death you mentioned to become a real quantum powerhouse?
The vision is ambitious, no doubt. It's to make Europe a global market leader, an industrial powerhouse in quantum, building directly on that scientific leadership we talked about. The strategy is really focused on leveraging those existing strengths, the research, the talent, the startups, the public funding structures already in place. But critically, it also aims to tackle that historical fragmentation in European efforts and really push for industrial deployment, getting things built and used. It's structured around 5 interconnected areas, or pillars. 1, research and innovation consolidating excellence. 2, quantum infrastructures building scalable, coordinated hubs. 3, strengthening the quantum ecosystem, so investing in startups, securing supply chains, integrating quantum into space, defense, security. 4, quantum skills building that world-class workforce. And 5, kind of underpinning it all, effective coordination of investments across Europe.
Okay, 5 pillars. Let's talk money then, the investment. How much are we actually talking about? How much is Europe committed, and where's some of that money gone? Any flagship examples?
We're talking significant numbers. Over the last 5 years, it's more than 11 billion in public funding. That's EU and national governments combined. Nearly 2 billion of that is directly from the EU itself. And yes, there are key initiatives. The big one is probably the Quantum Technologies Flagship, launched back in 2018. Think of it like a long-term, large-scale research mission. It has a 1 billion EU budget. The goal there was really to kickstart a competitive European quantum industry. Then there's the European Quantum Communication Infrastructure Initiative, or EuroQCI. That's been going since 2019. All 27 member states are involved, working with the Commission and the European Space Agency, ESA, to build an EU-wide super-secure quantum communication network. And more recently, since 2023, the European High-Performance Computing Joint Undertaking, the EuroHPC-JU. They've signed deals with 8 sites across the EU, places like Czechia, Germany, Spain, France, to host the very first European quantum computers. And importantly, these will be integrated with existing supercomputers. That initial batch of computers, that's about 140 million total investment, split 50-50 between the EU and 17 participating countries. Oh, and actually, 2 analog quantum simulators are already up and running in France and Germany under EuroHPC CJU too.
That integration with supercomputers? That sounds really important. Why that hybrid approach? Does it mean pure quantum computers aren't expected to just solve everything on their own?
Precisely, yes. That integration is absolutely key. It acknowledges that, while quantum won't be the answer for every single problem, we're building a hybrid system. The classical supercomputers handle the massive data preparation, the orchestration, the parts they're good at. And the quantum processors, they're reserved for those specific, incredibly hard calculations that classical machines just choke on, problems that might take them, thousands of years. It's the synergy, quantum accelerating the really tough bits, classical managing the rest. That's where the breakthroughs are likely to come for really complex stuff like drug discovery or designing new materials.
That makes a lot of sense. Okay, so we have this huge ambition, serious investment. What about the direct economic benefits? Will this strategy actually deliver on growth and jobs for you listening?
Absolutely, that's a core goal. The strategy is explicitly designed to foster innovation, yes, but also to accelerate commercialization. That means creating entirely new market opportunities, whole new industries, potentially. The expectation is for thousands of new high-skilled jobs, particularly in deep tech, engineering fields right across Europe. Ultimately, the aim is to really drive the growth of a European deep tech sector focused on quantum, which some estimate could be worth over 150 billion globally by 2040. It's about nurturing that whole ecosystem.
Thousands of high-skilled jobs, 150 billion industry by 2040. I mean, that's a massive target.
Right.
How will the EU actually attract the investment needed, both public and private, especially given how cutting-edge and maybe risky this feels to some investors?
Yeah, attracting investment is crucial. They're actively encouraging both public and private funding, using established EU mechanisms like the European Innovation Council, the TechU Scale-Up Fund, the European Investment Bank. But critically, they're also setting up co-investment programs and offering guarantees, things to basically lower the risk profile for private investors, make it more attractive. There are also specific initiatives like publicly backed private funds designed to help promising quantum companies scale up. Support for industrialization, too. Think pilot lines for making quantum ships, a shared quantum design facility. And maybe most importantly for smaller players, setting up that Europe-wide network of open-access quantum testbeds and competence clusters. This gives startups and SMEs access to expensive testing and validation facilities they couldn't possibly afford on their own. Huge barrier removed. Plus, the EU aims to act as a lead customer for early quantum systems, help with IP strategies to keep tech in Europe, and of course, train the workforce.
Right, that access to infrastructure, democratizing it, that seems vital for startups. And you touched on another common bottleneck for emerging tech, the skills gap.
Hmm.
How's the EU tackling that specifically for quantum, making sure there are enough skilled people to actually drive this revolution?
Yeah, the skills gap is definitely a major focus. It's being tackled on multiple fronts. The plan includes establishing a virtual European Quantum Skills Academy. This isn't just, another online course list. It's meant to offer clear, standardized paths to masters and PhDs specifically in quantum tech, building that pipeline of specialized talent. They're also launching mobility programs, helping specialists move between research centers and industry across Europe, share knowledge, collaborate more easily. And there are specific initiatives looking at retraining existing professionals who maybe want to shift into quantum, plus programs to get younger people interested early on, competitions, school projects, that kind of thing.
Okay, so skills are being addressed. You mentioned earlier quantum sensing having quite immediate impacts, but it often gets less hype than quantum computing. Is Europe seeing a clearer path to commercialization there? And how does sensing fit into the strategy from the get-go?
Quantum sensing is definitely a vital piece, and yes, it's an area where we're already seeing that faster transition from lab to application. These sensors can offer really significant improvements in performance, accuracy compared to classical ones. Think fields like gravimetry measuring gravity variations, magnetometry, inertial navigation. This isn't so much about processing power, it's about ultra-high precision measurement. So the Commission is investing quite heavily in pan-European quantum sensing infrastructures, like a network of quantum gravimeters, some fixed, some mounted on moving things like drones or ships. Imagine the uses of precise monitoring of underground resources, water levels, tracking volcanic activity, detailed Earth observation. And this ground-based network is even planned to link up with a future European space gravimetry mission for even more precise data from orbit. It's a field with huge near-term commercial potential.
This whole strategy, it just sounds like such a massive undertaking. Coordinating across so many countries and institutions. How does the EU actually ensure it gets implemented effectively? What's the governance look like? And what are the next concrete steps?
Yeah. Effective governance is absolutely critical for something this complex and ambitious. They're setting up a high-level advisory board. This will have top European quantum scientists, well-known tech experts, even Nobel laureates, providing strategic advice. There's also a cooperation framework being set up with the member states. This is key for consistent implementation across both EU and national programs. It'll coordinate progress on those 5 strategic pillars we discussed, and crucially, keep an eye on the security and resilience of quantum supply chains. And of course, maintaining close links with the whole European quantum community, universities, startups, industry, constant dialogue. As for next steps, well, they'll continue rolling out the Quantum Europe Research and Innovation Initiative under the EuroHPCJU. That's about structured cooperation, shared research goals. We should see more initiatives launching soon, too. Continued investment in those quantum computing facilities via EuroHPCJU, standing up the secure quantum communication infrastructure, EuroQCI, likely under the Union's new IRS satellite constellation program, and deploying new quantum sensing systems, for example, quantum magnetic resonance imaging, MRI devices in European hospitals. The aim there is faster detection of things like cancer or neurodegenerative diseases. Plus, continuing to strengthen that quantum startup ecosystem and formally establishing the virtual European Quantum Skills Academy as a central hub to training. And looking a bit further ahead, there's talk of a Quantum Act proposal expected around 2026. This sounds like it could be quite significant, not just funding, but maybe a foundational legal framework, perhaps a bit like the EU's AI Act, aimed at really solidifying Europe's leadership and tackling the big economic and security questions quantum raises.
Wow. What an incredible deep dive into Europe's quantum ambitions. We've really unpacked a lot there, not just the science, but the whole strategic vision and the direct implications for innovation, jobs, security, right across the continent. It's clear the EU is making a really significant, calculated bet here to lead the way.
It really is fascinating how something seemingly abstract like quantum mechanics is becoming so tangible, so relevant to our daily lives and so quickly. Understanding these strategic moves, these big investments, it really forces us to think critically about how technology shapes our future, doesn't it? And why leadership in these deep tech fields matters so much.
It certainly does. So here's a final thought for you, our listener, to maybe mull over. With quantum technologies poised to change so much, what new, maybe currently seemingly impossible tasks might you be able to tackle in your own life or your work thanks to these advances over the next decade? And maybe think about the broader societal shifts, too, as these incredibly powerful dual-use capabilities become more widespread.
Yeah.
Definitely something to keep a close eye on.